Hello there, this first video is going to discuss the writing formulas and naming compounds. This was from chapter 20 in your textbook. So we're going to just dive right in here with a few examples from your review packet. This is under number 7. CaI2, we start by identifying the metal in this, which is calcium. So we write the name calcium. And then iodine, we change to iodide. Good. Alright, second compound, N2O4. The first element is a non-metal, so instead of using the ionic names, we're going to use the covalent naming system, which means prefixes. So 2 means di, so di-nitrogen, we just named the first element. Then we look at the subscript for the second element, it's 4, so the second word begins with tetra. And then the element is oxygen, so oxide, I-D-E at the ending. Third compound, Al2O3. The first element is a metal, and so we're going to just look that up. It's aluminum. Don't change anything. O in the second position, so we say oxide, the root of the element, and then I-D-E. Al2SO4 this is a special kind of ionic compound with a polyatomic ion, that SO4, which remember we are not changing, that 4 is part of the symbol for sulfate. And so we just write the name of the metal, as we normally do, aluminum. And then here's where this compound's a little bit different. SO4 is sulfate, ATE at the ending. We do not change the ending. That's how we know this compound is a polyatomic containing ionic compound. Next compound, Fen. Well, Fe is iron, and notice that iron is a transition metal. It's over here in the middle of the periodic table. What's special about the transition metals is that they can have multiple oxidation states. So we can't just look at it like lithium and say, oh, it's group 1 plus 1, or beryllium, group 2 plus 2. Instead, we either have to be given it as a Roman numeral in the problem, or, which is what we're going to do in a second, we have to look at the formula we are given and work backwards. So nitrogen, we know from the periodic table, is a -3. It's 3 places away from a noble gas. So nitrogen gets a top number of -3. Compounds can't have any charge, which means this one iron has to cancel out that -3 all by itself, so that iron has a +3 charge. And so we name this iron, because that's the name of the metal, and then part of the same word we put a parentheses, and because the iron has a charge of 3, we put a Roman numeral for 3. Close the parentheses, and then our second word we just name according to the regular ionic rules. So nitrogen becomes nitride. Alright, next compound, ZnBr2. Well, zinc is a transition metal, however, it is one of the 3 exceptions, silver, cadmium, and zinc, which means it does not need a Roman numeral because it only takes on 1 oxidation state. And that oxidation state happens to be a +2. So we just name this like a regular type 1 ionic compound. Zinc, Br, is bromine, so it becomes bromide, IDE. Alright, Cu, parentheses, NO3, parentheses, 2. Well, Cu is copper, another transition metal, over here in period 4. So we're going to write copper. I know I need a Roman numeral because it's a transition metal, so I'm going to put some parentheses, and we'll come back and fill in the Roman numeral in a second. NO3, if we look that up in our reference tables, we see that the polyatomic ion with the symbol NO3 is called nitrate, ATE. Alright? The other thing our reference tables tell us is that nitrates have a -1 charge. Well, there are 2 nitrates in this formula, and so there's a -2 in this negative path of the compound. Compounds can't have a charge, so it has to add up to 0. Therefore, metal has to balance with a +2. There's only 1 atom of copper in this formula, so that +2 is on each individual atom of copper, so it's copper 2 nitrate. All right, next formula, CO2. C is carbon. It is a non-metal, and so we're going to use the prefix system for naming. Now, we don't say, and this is key for this particular formula, we don't say monocarbon. In the first position, if the subscript is a 1, we can drop the mono. So instead of monocarbon, we just say carbon, and then 2 is di, and oxygen becomes oxide, so carbon dioxide. NH4OH, well, I immediately know that this is going to be some sort of ternary compound because there are 3 separate elements in this formula. So I look up in my polyatomic list in our reference tables, NH4, and find that its name is ammonium. And I just write that down. OH, I also look up because it's also polyatomic, and I find that it is hydroxide. Now this is one of those polyatomics that happens to end in IDE instead of ATE or ITE, but we're not changing the ending. We're just writing it as we see it in the chart. RBF, we look up RB, find that it's rubidium, an alkali metal. So rubidium, F is fluorine, becomes fluoride. CCl4, okay, again, carbon is a non-metal, so we go to the prefix system. No prefix of mono on the first position, so carbon, then we have a 4, that's tetra. And Cl is chlorine, so I changed that to chloride. IDE is the suffix. Ag2Se, well, Ag is silver. Again, it's a transition metal, but it's one of those 3 exceptions. It's a +1, which means we don't need to write the Roman numeral. So we're just going to say silver, and then we'll look up Se, and we will see that it is selenium. So second word, selenide, IDE. Next compound, Pb parentheses CO3 parentheses 2. Well, I look up Pb and I see that it is a metal. Now, this metal is not a transition metal. It's not over here with those other transition metals. However, it acts like them in compounds, in that lead can have a +2 or a +4. We don't know just by looking at its position in the periodic table. Same with tin. Those are the 2 exceptions that do take on Roman numerals, even though they don't look like they should. So it could be a +2, it could be a +4. Our job to figure out which one it is. So I'll just go ahead and start by writing lead, putting parentheses, and leaving them blank for now. Moving on, CO3 is a polyatomic ion. So I'll look in my list of polyatomic ions, CO subscript 3 is carbonate. But the other thing I need to know from that is that carbonate has a -2 charge. There are 2 carbonates, so I multiply that by 2 to get a -4. Compounds have no charge, so I cancel it out with a +4. And the last step, ask myself, how many atoms of lead are in this formula? It's just 1, so that +4 only belongs to each atom, so I write it as a 4. Okay, IV. Lead 4 carbonate. All right, iron again, so we know right away that this is going to be some sort of Roman numeral, so I'm going to write iron, parentheses, leave some space for a Roman numeral.
Mabry Watson, please report to the office. Mabry Watson to the office. Thank you.
Second element is sulfur, which becomes sulfide. All right, now we have to figure out what goes in that parentheses. Well, sulfur on the periodic table, group 16, it's in the oxygen family, so it's -2. It's 2 steps away from argon. -2, there's only one of them. We cancel it out with a +2. There's only one iron, so that +2 doesn't need to be divided over anything, so it's iron 2 sulfide. All right, SO3. Now, this doesn't have any oxidation number at the top, so we know it's not talking about the polyatomic ion sulfite, ITE. Instead, it's a neutral compound, so we name it like any other covalent compound because sulfur is a nonmetal over here on the right side of the periodic table. There's only one of it, so it would get a mono. We don't have to write it because it's in the first position, so we just write sulfur. And then there are 3 oxygens, so tri, ox, and then ide, because it's in second position. Sulfur trioxide. Next video, we'll deal with writing the formulas from the names.